Okay, so if you see my screen, you should see the question number 1, then question number 2, and so on.
Yeah.
All right. All right, so the first one here, it says 0, 0 is the vertex, so that's where it comes down and hits the bottom, right there at 0, 0. And if it goes through point -3, 3, that means that those values have to be on the graph. One way that we can do that, I mean, it doesn't, there's a lot of things that could happen here. For number 1, you imagine there's an A in front. So if you substitute 3 for y and -3 for x, you would then solve for a.
Okay.
So if you do that, you get 3 equals a times 9. You divide both sides by 9, and you get a equals 3 over 9, which equals 1/3. So you write this equation down here, y equals 1/3 x squared. This is because the vertex is still 0, 0. That's why that's working out so nicely. If it wasn't 0, 0, like in number 2, we have to do something completely different. So let me grab number 2 here. Let me just snip it again. We'll just paste it again here. So for number 2, there's a vertex shift. So this is when you really want to use the vertex form of a parabola. So that vertex form is y equals a x minus h squared plus k. H comma k is your vertex. So that means that 1, 5, that's h and that's k. So we got y equals a x minus 1 squared plus 5. Is that clear up until that point?
Yeah.
Okay, great. So we will find a by using the other point. So use the second point to find a. Now keep in mind that you could have done all of this for number 1. You just would have made h and k 0, so it would have reduced to this other form. So we're going to use that second point, which is 2, 1. So we're going to put 1 in for y, 2 for x, and we're going to simplify. So we're going to subtract 5 from both sides. You get -4 equals a. 2 minus 1 is 1. 1 squared is 1. So a ends up equaling -4. So you take this form, bring it down here. Y equals -4 x minus 1 squared plus 5. Okay, can we move on to 3 through 5, or is there any follow-ups to those questions?
Yeah, we can move on. I think
Okay.
I got it.
There's definitely an emphasis here on solving quadratic equations and graphing them and stuff like that. Okay, for each quadratic function, identify the axis of symmetry, the vertex, and the domain and range of each function. Okay, so the correct order here is actually, you want to find the vertex. The vertex leads you to the axis of symmetry, and then the domain and the range here. Okay. For some of these, let's see here. Actually, all 3 of these are in what's called these are in kind of like a standard form, which is this ax squared plus bx plus c form. The form that we talked about in the previous one, the vertex form, it's in this form, y equals a x minus h squared plus k. Depending on the form that it's in, there's sometimes like a preferred way of doing the questions. So everything we do here 1 through 4 will be based on the fact that it's in standard form, whereas you might do it differently if it was in vertex form. So for number 3, it says y equals x squared minus 7. The vertex has x coordinate minus b over 2a, and that refers to these up here, this ax squared plus bx plus c. So in your problem, your
Yeah.
a equals 1. That's the number in front. That's the number in front of x squared that's not written. The original problem actually could be written as 1x squared plus 0x minus 7. So that means that your b is actually 0. It's the number in front of x. So that means that this minus b over 2a is minus 0 over 2 times 1, which is 0. Is that
Yeah.
okay? Is that clear? So that's the h value. That's the first part of the vertex. The y value of the vertex you get from putting this value of 0 back into the original function. So 0 squared minus 7, which ends up being minus 7. So you have a vertex of 0 comma minus 7. Now you might have been able to look at that because the graph of x squared looks like this. X squared minus 7 is shifted down. It shifted down 7 units.
Yeah.
Okay, but the process I just showed you, it works for all the questions. So there's no, you haven't lost anything by doing it sort of this long way. So that's the vertex. The axis of symmetry, it is the x coordinate of the vertex. So it's x equals whatever the x coordinate of the vertex is. So in this case, it's x equals 0. The domain for all of these, for all, is minus infinity to infinity, or sometimes it's written as all real numbers. Sometimes it's written in set builder notation, x such that x is an element of the real numbers. Do you know if you're using interval notation?
Yeah, we use interval.
Okay, that's the best one. It's kind of not too mathy, and it's pretty clear. The range, there's actually two types of ranges that you might see. It depends on whether the parabola opens up or whether it opens down. So if it opens up, it's going to be the y coordinate of the vertex, which we sometimes call k, comma infinity. If it opens down, it starts at minus infinity and goes up to the y coordinate of the vertex. So let's take a look here. Does this one open up or down? Number 3, this 1x squared minus 7, kind of already showed you over here.
It opens up.
It opens up. So since it opens up, it's this top one. The y coordinate of the vertex was minus 7 to infinity.
Okay.
So everything I just said applies to number 4. Number 4 says x squared plus 2x plus 6. This is in standard form. And that, what I mean by that, that's the ax squared plus bx plus c. A is the number in front of x squared, so a equals 1, b equals 2, and c equals 6. What I would like you to do is find the x coordinate of the vertex, okay? And then I want you to use that to find the y coordinate of the vertex. You're taking whatever that is and putting it back into the original. So go, give yourself 60 seconds and see if you can do that for me, please.
Okay. Okay, I got -1, 5.
Okay, so the b value is 2, so it's -2 over 2 times 1, because a is 1. So that makes this -2 over 2, which equals -1. So then, did you put that back in to the original?
Yeah.
-1 squared plus 2 times -1 plus 6. All right, let's take a look here. So -1 squared is 1, minus 2 plus 5. So I get +3. I'm sorry, +4 for this. So I get y equals 4. So the vertex is at -1, 4. I think you said -1, 5. Maybe you just had a small sign error.
Wait,
So
it you add
plus
6.
6. Plus 6. I had an error here. -1, 5. Thank you.
Okay.
Good. Good. Okay. The axis of symmetry is x equals -1. It's just whatever that x coordinate is. The domain is always -infinity to infinity. The range is based on whether this opens up or down. Does this open up or down? And it's based on that, whether it opens up in this case.
Yeah.
So since it opens up, you can go back and look, but the smallest value is the y value of the vertex, 5, infinity.
Okay.
Great. Okay, so number 5. Number 5 here. I want you to try and find the vertex again. Everything kind of stems from the vertex. If you can find the vertex, you can get most of the other stuff in this problem. So again, give yourself a little bit of time here, find the vertex, and I'll check back in with you in about 30 seconds.
Okay.
All right, did you get the x value?
Yeah, I got 5/2.
Okay, so y equals x equals minus b over 2a minus 5 over 2 times -1, which does reduce to 5/2. So this is that time that students hate. It's like, oh no, I got a fraction, I got to square it. Yeah, it's not ideal, but it's possible that you might get this on a test. So we'll just cover how to do this again. So the negative comes after you square it, so it's going to be -25 over 4 plus 25 over 2 minus 3. And the key here is just to remind yourself to make everything a common denominator of 4 minus 25 over 4 plus 50 over 4. You just double the top and bottom. Here you have to multiply top and bottom by 4. So you had -37 over 4. So this ends up being, these two give you -37 over 4, positive 50 over 4. So that's 13 over 4. You can also just use your calculator to do that as well. So you got your vertex, 5/2, comma 13 over 4. The axis of symmetry is x equals 5/2. The domain is -infinity to infinity. The range this time, though, because it opens down, it's going to be minus infinity all the way up to the y coordinate of the vertex, and it's always a bracket.
Okay.
Okay, next grouping of questions. Great. We actually get to do some things that are a bit faster. You could reasonably think like, man, maybe we aren't going to get through very many of these today. The next little grouping here will go pretty fast. We'll take, we'll just, the sort of the thing here that you have to remember is square root of negative 1 equals I, and I squared equals negative 1. Okay. So for 6, do you know 6? Do we need to cover that? Can you tell me the answer?
It's 4i.
It is 4i. Number 7, I'll write down here just because there's a few more things going on. The square root of negative 9 is really the square root of 9 times the square root of negative 1. This 4 is still out in front. The square root of 9 is 3. You are multiplying. Square root of negative 1 is I minus 2. You can combine these, so it's 12i minus 2.
Okay.
All right, so number 8. Number 8 is a FOIL question. FOIL. It's if you were doing number 8 with x's, you would know that you would just FOIL this. So I'd like you to try and FOIL this because you know how to do that. And I'll give you 30 seconds here. And I'll just remind you that I squared equals negative 1. Give that a try, please.
Okay.
Okay, how are you doing on that?
I got 31 plus 14i.
Okay, so I'm gonna write out the expansion, and the thing that you're gonna see here is that this is negative 1. So you have 16 plus 14i, 31 plus 14i. Yeah, you got it. The next one you're gonna see is, sorry, I got sidetracked with where our stuff is. This one is adding and subtracting. So you're gonna combine like terms after you distribute the negative. So you'll see here now that I made it a little bit bigger, that negative goes into each of these. So it's minus 3 plus 2i, minus 6 minus I, and then you combine like terms. You can combine these and combine these. So that makes it minus 9
So it's just
plus I.
okay.
Some instructors prefer you to always put it in the form, A plus BI. So this makes that work. Just depends. Just depends on how particular your instructor is. Did you have a question? Because I kind of interrupted you and I didn't need to do that.
Oh. No, I got it. He always makes us put the real number first.
Okay.
So
Easy enough here. Now, so the what happens here is you're up to number 10, and maybe you're like, oh, I got it, no big deal. 10 requires a special sort of understanding of these problems, how to do it. There's what's called the complex conjugate, and I usually spend a lot of time working on what is the complex conjugate, and all it is you change the operator. So the complex conjugate, you change that operator, and you multiply the top and bottom. I'm sure you've seen this in class. The top now is a foil problem. The bottom is going to reduce to a number. Okay.
Okay.
So this is this is one of those where I'll work it out here, but I'd like you to try first, expanding the top, foiling the top, and then working on the bottom. It does reduce to just a single number. So take about 60 seconds and see if you can work that out.
Okay, is it 6 plus 8i over 5?
Okay, I'm going to work it out just so you've got it here in your notes as well. It sounds reasonable. The bottom is definitely 5. So on the top, you get 8 plus 4i plus 4i plus 2i squared. On the bottom, you get 4 minus 2i plus 2i minus I squared. And you've correctly stated the bottom becomes 5. The top becomes 6 plus 8i, which I think is what you said. The last thing here is to write it as 6 over 5 plus 8 over 5 times I.
Okay.
All right, so the nice thing is if you understand each of those examples that we did for 6 through 10, you'll probably see at least one of each, and hopefully you just get all credit on those because they're not really the hardest stuff here in the section. They're just good opportunities for points. Okay, factor each expression completely. So we're on to sort of what appears to be a completely unrelated question, and then we go to solving, and solving relies on factoring and then this square root of -1 stuff that we just did. So it's like we're going to synthesize two concepts. The very first type of factoring you should always try is GCF, greatest common factor. It's applicable in the first one, but not the second one, and not the third one either. Like these are each 3 different types. So there's not really, like your instructor could give you, there's about 8 different types of factoring, and you're only seeing 3 of them here. So it's possible you get one that isn't on this list. So I'll just make that clear from the start here. 2y squared minus 8y. The GCF can be either a number or a letter, meaning exponent or power, or both. So in this case, it's both. And if you don't know what it is, or if you guess wrong, you just get to do it again. It is 2y. This becomes y minus 4. I'll remind you that sometimes students don't know when they're done here, and it is a little bit of a like you have to really know this to know when you're done. So I really can't say, oh, you're done when this happens. You won't know unless you sort of like you have to know that you've done it right to know that it's done.
Yeah.
This is the case where a does not equal 1. A is the leading number. Sometimes you can factor out a number from all 3 of these, but you can't in this case. So the technique here is you multiply 3 times minus 3. and that gives you minus 9. So 3 times minus 3 equals minus 9. And then you look at all the factors of this that add up to 8. So there's like minus 1 and 9, 1 minus 9. There's minus 3 and 3, or 3 and minus 3. This one, this first one though, adds up to 8. So what you do is you rewrite 3x squared, okay, and I'll do it this way, plus 9x minus 1x minus 3. So the order doesn't matter. Like you can put the 9 first, the minus 1 first, doesn't matter. And then you do a factor by grouping. You look at these and you figure out like what's the GCF between these, and it's kind of like the first problem. It's 3x plus 3. No, 1x plus 3. Erase that because that will not look right if I just cross it out. So it's just x plus 3. X plus 3. And you immediately write what's in parentheses over here, and you figure out what goes in this position so that when you distribute it in, you get minus x minus 3. We'll know that to be minus 1, minus x minus 3. So now you got 3x minus 1 times x plus 3.
Yep.
Great. Let's see. So 13 can be done the same way, but 13 is actually a perfect square trinomial.
Oh yeah.
And that's why I meant like, this is like, these are 3 different ones. I mean, I can see this because I mean, I write worksheets that have, lots of these on there, and you sort of get a feel for them. So how did I know? Well, you take the square root of the first thing, 9w squared. You take the square root of the last thing. So this is 3w plus or minus, and this is 5. You multiply them together. When you multiply them together, you get plus or minus 15w. And then when you double it, you get plus or minus 30w, and that's what you have back here. This matches that.
Yeah.
So what these do is these tell you what the binomial is. It's this times this, but they're the same. That's why it's a perfect square trinomial. It's just 3w minus 5, 3w minus 5. Sometimes it's written, maybe a lot of times it's written like this. It just depends on what your instructor is looking for.
Yep.
Great.
Okay.
Move on to 14 through 16.
Yeah.
Okay, so we're solving each quadratic equation. To solve each quadratic equation, you have to use a technique that we just talked about. Like you're probably going to use some sort of factoring or square root property. Or you might use completing the square, or you might use quadratic formula. But probably it's factoring, and that's why they had to do factoring in the previous one here. So let's look at 14 first. 14 is difference of squares. Now you don't have to do it as difference of squares, but it is a difference of squares problem. So it's yet another type of factoring. That's a squared minus b squared becomes a minus b, a plus b. The game is to figure out what squared gives you 25. So that's x squared minus 5 squared. So this produces x minus 5, x plus 5. So when you set those each equal to 0, that's the solve part. That's the additional step. So really this could be it could say factor then set equal to 0. You set each of these equal to 0. X minus 5 equals 0. X plus 5 equals 0. And you get x equals 5, x equals minus 5. You might have said, hey, well, why don't we just move the 25 over, take the square root of both sides? You can definitely do that. It's up to you. You have options.
Yeah.
Okay. So this is where I feel there's a little bit of disconnect because 15 kind of looks like you can factor it to solve it, and you cannot, because you're trying to find 2 numbers that multiply to 3 but add up to -2. Well, these are the only factors of 3. Do any of these add up to -2? No. I mean, these diagonal ones do, but that's not what we're trying to do. So this is not factorable. And you have to know what to do when it's not factorable. Do you know? Do you recall from class?
Solve using the quadratic formula.
Yes, the diabolical quadratic formula. So that's why we had to figure out what this whole like a equals 1, b equals -2, c equals 3. Not because we're trying to find the vertex now, but because we are trying to find the quadratic formula. So that is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to substitute those numbers in. B is -2. That's really bad. So we have -2 plus or minus the square root of -2 squared minus 4 times 1 times 3 all over 2 times 1. So that's 2. Inside here, I'm just right upside, it's 4 minus 12. That's the square root of -8 all over 2. So the reason you had the practice there, number 6, 7, 8, 9, 10, is so that you hopefully know how to handle this square root of -8. What does that become? Square root of -8. I'll let you get caught up if you need a little time.
8i.
It's a bit more. So the square root of 8 is something a little bit different. So remember, 8 is broken apart
2.
as 2 and 4, 2 and 2. So it's 2i square root 2 over 2.
Oh.
If that's not clear, I can go through that a bit more.
Yeah, I think I get it. It's just, I thought the I would be after. I thought it was like 2 root 2i, but you have to.
You can put the I over here, where you could put the I here. It's just preferred there.
Okay.
Sort of preference. Now we're not quite done because you have to divide both of these by 2. So that's 1 plus or minus I squared root 2. So that felt like a lot of work to answer that question, whereas the previous ones weren't as much work. The 14 wasn't as much work to solve, but you still with me? Sorry, there's just a little bit of a delay.
Yeah, I can hear you.
Okay, yeah, sometimes I just this format as you just don't know. I'm not even sure seeing you. All right, so the next one is sorry, I can't find it. There it is. Okay, x squared minus 8x equals -6. You definitely want to get everything on one side of the equation before you start. So you get x squared minus 8x plus 6 equals 0. So again, you're trying to find the factors of 6. Do any of them multiply or add up to -8? And you can see right away that they do not. So this one is considered prime.
Okay.
That means you can't factor it, not factorable, which means that you have to use the quadratic formula.
Great.
So go ahead and give this one a try on your own. I give you a little bit more than a minute because it could take a while, and see how you do on that one, okay?
Okay. Okay, I got 4 plus or minus root 10.
All right. Do you know about, do you use like any sort of online math things to help with these kind of lessons when you're doing your homework or anything like that?
No, I don't.
Okay, so I was just gonna suggest, like, if you go to like something like I use Wolfram Alpha, and there's many of these things, and if you just type in exactly what you have written here, and you don't have to tell like to solve it, it will sort of assume that you want to do certain things. You do end up getting that as an answer. So
Oh,
definitely on the right track there. So okay, so 17. We'll move on to 17. Also use and yes. Solve the following system of equations. So in 17, we have both a a parabola and another parabola. So it's possible that they intersect once, twice, or no times. So we'll try to find that out here. Because they're both already solved for y, you can set them equal.
okay.
And that works out really nicely here because you get 3x squared minus x plus 1 equals 3x squared plus x minus 1. And when you start moving stuff around, you'll see that these cancel. If you subtract 3x squared from both sides, it's gone. I'm going to subtract x, so minus 2x, add 1, plus 2 equals 0. Normally you'd have a quadratic here, but since you don't, we'll just move this 2x over here, so you get 2 equals 2x, divide by 2, x equals 1. To find y, you have to put this back into one of the other equations. It doesn't matter which one. I'll just choose the second one. So y equals 3 times 1 squared plus 1 minus 1. So this is 3 times 1 plus 1 minus 1. These go away, so you end up getting 3, so that ordered pair is 1 comma 3.
Okay.
'18 is probably more complicated. Yeah, it is. 18 is a parabola and a line. I know I'm telling you this verbally, but you could always draw the pictures. You have a parabola and a line. They could hit twice, they could hit once, or they could not hit at all. We don't know. And that's one reason you go about solving these things. Since they're already solved for y, you can go ahead and set them equal.
Okay.
So you have minus x squared plus 2x minus 3 equals 4x minus 3. Normally we move everything left, but I really want a positive x squared, so I'm going to move everything right this time. So that's like adding x squared, subtracting 2x, and adding 3, all over here. So we're going to write the x squared first. You're going to have 4x minus 2x, that's going to be plus 2x, plus 3 minus 3, so that ends up being 0. Sometimes students are like, I don't know what to do here, I don't know what to do here, because you're used to having that number there. Well, the very first type of factoring is GCF, and there's an x in both of these. So you can factor that x out, and then you can set each of these equal to 0. So you can set x equal to 0, x plus 2 equal to 0, x plus 2 gives you x equals minus 2. These are only the x coordinates. You still need to find the y coordinates. That means we have a situation like this two solutions where we have it hitting it twice. That's why we got both of these as possibilities. So if x is 0, we have to find y. You can use either equation. I'm going to use the 4x minus 3 equation because it's simpler. That equals -3. So we have our first intersection at 0, -3. If x is -2, I'm going to use the same y equation. Doesn't matter which one you use, but choose the simpler one. This becomes -8 minus 3. That's -11. So we have -2 minus 11.
Okay.
All right. We probably don't have enough time to do all of these that are left. I don't know if you had to get up through 27.
No, just 23.
Okay, we probably will have the ability to finish all of these then. So we'll start with 19. 19, I'm going to use Desmos to solve. And I hope you're allowed to do that. Do you know if you are, will be allowed to?
Yeah. We can.
Can. Okay, great. So I'm sharing that screen now. And we talked about this, I think, last week. If you graph them as is, which is totally normal, like that's what I would do if I were a student. Again, I would just not sure why I wouldn't. You will see that the overlap is where the solution space is. Okay.
Yeah.
The suggestion I made is to change the order of these things so that you could see the white space instead. Like if I were a student and I could snip in this into a test, this is what I would definitely put this into into my that's what I would show my instructor.
Yeah.
And I hope you can do that this time, because I think last time you lost some points for graphing, and graphing is always one of those things where it's like it's not really meant to be done by hand anymore, but that's what they had to do. Is it okay if we move on to the next one, or do you want me just to move right to 21 through 23? Because 20 is exactly like 19.
Can we do 21?
Yes. Okay. So I'm going to switch back to sharing the notebook space here that we've been working in. Okay, are you able to see this 21 through 23 on my screen now?
Yeah, I can see it.
Great. Evaluate the discriminant of each equation. The discriminant is from the quadratic formula. The discriminant is just this part. It's the d. It has nothing to do with the square root. It's just so the discriminant is b squared minus 4ac. There are three possibilities. The discriminant could be greater than 0. This means it has two real solutions. The discriminant could be exactly equal to 0, and that gives you one real solution. This is what's referred to as a double root. It's when it hits the axis, touches the axis. Maybe touches is a better word for it. If d is less than 0, there are two imaginary solutions. Okay? So to do these problems, you have to be able to find the discriminant. Okay, I'll get the d value, whatever it is, and then match it up with this list that we created. So let's do 21. We'll have time to do them all. 21 says x squared plus 6x minus 7. So a equals 1, B equals 6, and C equals -7. So the discriminant, B squared minus 4AC, is 6 squared minus 4 times 1 times -7. So that's 36 plus 28. It equals 64. 64 is greater than 0. So we can say the discriminant is greater than 0. And then you just scroll up and you'll have this memorized in your notes, but it has 2 real solutions. So you'd say 2 real solutions. It's not okay to say just 2 solutions. You have to be very specific, real, imaginary.
Okay.
Let's look at 22. 22 says 3x squared minus x plus 3 equals 0. A equals 3. B equals -1. C equals 3. I'd like you to find the value of the discriminant, please.
Okay. Is it -35?
So we got b squared minus 4 times 3 times 3. So it is -35. That means it's less than 0. That means what? How many solutions does it have, and what kind are they?
It has 2 imaginary.
2 imaginary. Perfect. All right. So 23, we'll do real quick. Can you calculate the discriminant for that? A is -4, B is -4, and C is 1.
I got 32.
So 16, yep. So it's 32, which means it's greater than 0. So that means it has 2 real solutions.
Got it.
All right, well, that concludes the lesson for today. I will send you the PDF notes and the video as soon as the video uploads. Sometimes it's been 5 minutes, sometimes it takes 20 minutes, but I'll do that right away.
Okay, thank you.
You're
See you
welcome.
soon.
Bye now.